everyone, welcome to today's video. Today we are going to discuss IUPAC naming and drawing structures from IUPAC names. This is organic chemistry part 3. In the part 2 we have discussed about nomenclature rules and how to proceed to drawing compounds from a given IUPAC name. Today we are going to do exercise 12A. So it will be very helpful if you sit with your books. The first question that is there is question 1A, that is given is CH3, CCH3, CH3. I have discussed this question in the previous video also, so I am not discussing it again. It's 2, 2 dimethyl propane. Okay, it's 2, 2 dimethyl propane. Discussion already done. The second question is, let us draw the second question. This question I haven't discussed, so let's draw the question. So the question says CH3, then it says CH, then it says CH2, then it says CH3, then it says CH3 over here, and this is the question, right? Now, what you have to see? The thing you have to see is that the substituents will get the lowest possible locant, as I have already told in the nomenclature video. So who is the substituent? This person is the substituent, right? So this person should get the lowest possible locant, which can only be possible if you number it from this side, correct? If you start numbering from this side, this will get third position, which is not the lowest locant. We want the lowest possible locant. So to get the lowest possible locant, we must number it from this end, because from here it will get the second position, that is lower than third position, obviously. So numbering starts from this side, position 1, position 2, position 3, position 4. Okay, attached to second position. This is prefix, so we are writing in front 2 methyl. Done. This part sorted. Now how many carbons are there? 1, 2, 3, 4. 4 stands for but. All single bonds. This is the main chain, obviously. This is the main chain, obviously. We have also taken this part, but it will also remain the same thing. Okay. So this is the main chain where you are tapping 4 carbons. So it's butane, because all single bonds, 4 carbon is but. This is ane. So the name stands as 2-methyl butane. Clear? 2-methyl butane. So question 1B, answer is 2-methyl butane. Okay. Next one, let us see. Question 1 part C. Question 1 part C. What is it saying? H, CH, double bond, this. Okay. This is the question. This is the question. Number C. This is the question. Now, what to do in this case? If you are getting confused, make it a condensed formula. Make it a condensed formula if you are getting confused. Now your question will be, how to make a condensed formula? It's very simple. Making a condensed formula is not difficult. See, compressing this part, so it becomes CH2, correct? 2 hydrogen have been as CH2, then double bond. This becomes single CH, 1 hydrogen is there, and this becomes 3. So this is now the compressed formula, right? Condensed formula. So this looks better, this looks better. Now you can label it properly, more properly if you are having any difficulty. I am not saying that you will always have difficulty. It's only when you are having difficulty, okay? So how to label it? Number it rather. Again, as I have already told you, this person must get priority because this is double bond. So that's double bond must get priority. So for that you cannot number it from this side, but you have to number it from this side. Again, the double bond must get the lowest locant. Okay, So numbering starts from 1, 2, 3. Parent chain is always this only in this case. Obviously this, because nothing else is possible, right? Now, how many carbons are present? How many carbons are present? 3. So we can write prop. Double bond is present, so we can write in. Correct? But writing only this much will not give you marks. Then what will happen? You will get 0. Prop is okay. In is also okay. But something is there in between. Position. Position you have to mention. Though propene is not wrong. Propene is also correct. But what is the position? 1. That is why we are not writing. Clear? So even if you write, it's better. It's prop 1 in. Now you will say, why not 2 and why only 1? Because it's between 1 and 2. And we will choose the lowest locant. We will choose which one? The lowest locant. Lowest locant between 1 and 2 is 1. So we are writing 1 over here. Clear? Ignoring 1 and writing 1 in chemistry will not change your answer unless it is a numerical. Obviously, numerical, if instead of 1 you write something else, problem. Or if you miss out on 1. Right? Okay. So the answer is prop 1 in. Okay. Next, let's move on to question number D. Let's see what question number D says. Okay, question number D says, H3C, C, CH3, CH3, CH2, CH2, CH3. Okay. See this question, not a very difficult question. H3C, C, CH3, CH3, CH2, CH2, C2, CH3. Okay, this indicates also CH3. Okay, it's written in this format. No problem is there. This what is this? This part, if you can clearly see, this is C3H7. Can you see? This is C3H7. Understood? CH2, CH2, CH3 is present. So it's C3H7. C3H7 is propyl. So it's also an alkyl radical. So this is propyl. Understood? Now see here properly. Which one to be chosen as the main carbon chain? That is a big question. Right? Which one to be chosen as a main carbon chain? Now see, to understand this, you need to see what can be the chain. One chain can be this particular thing we are taking. One chain can be straight chain, obviously. One chain can be this one. One chain can be this one. One chain can be this one. Now see which one gives you maximum. First let us check this part. How many carbon? 1, 2, 3. 3 carbon. Fine. So as of now we are getting 3 carbon. Fine. Let us keep it 3 carbon. Now let us check this side. Okay. 1, 2, 3, 4, 5. 5 carbons possible. 5 carbon. So we will not consider 3 carbon. We are going to consider 5 carbon. So now this becomes our chain. Wait. Let us see what can be done. Straight chain also 1, 2, 3, 4, 5, 5. Straight chain is also 5. Fine. Now this part 1, 2, 3, 5. This is also 5. Clear? So 3 will not be considered. Instead we will be considering 5. Even this comes to be 3. But that is also we are not going to consider. So we are going to consider 5. That is this. So we are considering this chain because it looks more decent. That's it. Okay. You can consider bench chain. That is your choice. But this looks more decent. So I have just taken it. Clear? So main carbon chain according to me is this carbon chain. Okay. Let's erase this temporarily. Okay. Now let's write the name. Main carbon chain complete. How many carbon? 5 carbon. Ends with pent. All single bonds? Yes. N. Correct? First part naming done. Now methyl added. 2 methyl is added. Correct? So it's a dimethyl. Whenever there is a 2 methyl added, it's a dimethyl, space here between. Okay. Now where are those 2 added? First one is added at 2. Another one is also added at 2. See, naming from this side we are doing. Numbering we are doing from this side. Why? Same. Locant number should be less of the substituents. From here you name number, it will be 4. 4 is not a concern. We are numbering from this side. Clear? 1, 2. So this becomes first, second, third, fourth, fifth. Clear? So this is second. Second comma second dimethyl pentane. So the IUPAC name stands as 2,2 dimethyl pentane. Understood? 2,2 dimethyl pentane. 2,2 dimethyl pentane. Next question is question number 1 part E. Question number 1 part E. Let's see what does that question mean. Question number 1 part E. Okay. Part E. CH3 C Okay, this question, right? Main chain cannot be anything else other than the straight chain. No substituents attached. Only this much is there. So main chain is straight chain, right? Now the question is numbering. See from which end is the triple bond getting the least possible locant? Which side? This side or this side? From here 1, 2, 3. 1, 2, 3. Then 3, 4 between is the triple bond. From this side 1, 2. 2 and 3 in between, that is the triple bond. So which position? This side. So from this side we are going to name it. Clear? So this is going to be my first carbon. This is going to be my second carbon, third carbon, fourth carbon, fifth carbon. Understood? Understood or not understood? Okay. 5 carbons are there in total. So name ends with pent. Rather it starts with, because it does not have any prefix. Okay. Pent. Okay. Next. We know it is ine because it is having a triple bond. But where is the triple bond located? We cannot omit the position 2 over here. Why? Because it is not 1. 2 is a number. You cannot omit 2. Clear? So pent position is between 2 and 3. Least locant is 2. So you have to mention 2 ine. Right? You cannot mention, omit this word, this letter 2. 1 can be removed, but 2 cannot be. From 2 any number cannot be removed. Okay? Greater than 1. So this is pent 2 ine. Triple bond presence indicates ine. Position between 2 and 3. Least locant is 2. 2 over here. Total number of carbon is 5. Pent over here. Understood? This was question number 1 part E. Pent 2 ine. Pent 2 ine. Next question. Question number 1 part F. Question number 1 part F. Let us see. H single bond C, triple bond C, okay. Now let us see. If you are having again problem, compress this. Clear? You can compress this, but I will say not to compress it, else it will create confusions. Okay, it will create confusions. I will say not to compress. Okay, now how to do this question? Okay, first hydrogen are least bonded right now over here. Main chain, obviously this one. Main chain is obviously this one. Cannot be anything else. Wait, let me see. 1, 2, 3. Main chain is this carbon. Clear? Main chain is straight chain. Straight chain is going to be the main chain. Understood? This straight chain that is possible is going to be your main chain. And this 2 is going to be a substituent. Why? Now the question is, why? See, you will say that this chain is more than this chain. Fine, understood. But this triple bond cannot be in a substituent. It has to be in the main. Just like functional group you cannot place somewhere else. Similarly, this triple bond, it will be included in the main chain. Otherwise, it will not work. Clear? This has to be noted down. This triple bond will be in the main chain. So we will have to include this triple bond in the main chain. Moment we have it included, automatically that will become the parent chain. Clear? So parent chain is this chain, this 2 is the substituents. So that we are list further with. Now let us see numbering. Numbering will begin from this side, very much visible. 1, 2, and this is the third carbon. This is triple bond. The total number of carbon is 3. So it's but. Clear? But. Next. This is present between 1 and 2. So it's but 1. Bond is triple. So it's ine. But 1 ine. Now 2 methyls are present. Which carbon? Third carbon. How many? 2. So there is dimethyl. Where is it present? 3, 3. So the name stands as 3, 3 dimethyl but 1,9. 3, 3 dimethyl but 1,9. Understood? 3, 3 dimethyl but 1,9. Understood or not understood? We have taken the main chain as this one because we have to include this third bond, triple bond in the main chain. So we have to do this. Moment we have done that, we have seen that we have to label from this side. This to become the substituents. We have written it as dimethyl, 2-methyl, both attached to the same carbon, third carbon, 3, 3 but 1,9. Now if you have the question, why aren't we giving these two things the lowest locant? Right, we should have given, but we aren't giving that. Why? Because I have told in the last video also that there is again another priority that says that when there is a double bond, triple bond and some substituent is present like halogen, like methyl group, alkyl radicals, then the priority is given to the double or triple bond, then to this substituents. Clear? First priority is to this bond. Now if this bond and a functional group is there, then more priority to the functional group than to this particular part. Okay? So we are giving more priority on this one. Let this go wherever it wants. But when it is not there, we are giving priority to this one. Understood? This is the thing that you need to remember. Priority series. Okay? Next question. Question number 1G. Let us see what is there in question 1G. Question 1G. Okay, question 1G. CH3CHCl. 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 CHCl. Okay, this is the thing that is given to you. Yes. Okay. Now here, these two chlorine are the substituents. These two chlorine are the substituents. Now, do not write these two chlorine as Cl2 on some one carbon. If you modify this and remove this chlorine from here and put it over here as Cl2, no logic. Okay, this is not reaction going on right at this moment that you are combining this Cl2 together and forming. Then your compound is formed. How can you combine your compound? Clear? This is an arrangement. You cannot combine the Cl and form Cl2 in this. Okay, so be careful when you are writing this. Cl is here, Cl is here. You cannot combine those two Cl and write Cl2 at once. That is not possible in these cases. Okay. Now, how to name this type of compounds? A question is definitely there. No tension is there. See, main chain is this one obviously. How many carbon? 1, 2, 3, 4, 5. Name from this side also. 1 will come as 3. 1 will come as 5. No, not 5. 1, 2, 3. 1 will come as 4. 1 will come as 3. And from here it is coming 2 and 3. Who is giving the lowest possible locant? This side. Because if you name it from this side, here 3 carbon, here 2 carbon. So obviously this side will give you lowest locant. So from here this will become 3 and this will become 4. So this is getting higher, and from here it is becoming 2 and 3 will lower. So we will be having it from this side. That you have to understand. That you have to number and see that from which side it is getting lower. How many total? 5. So we can write pent, all single bonds present, main chain is this. Okay. So it's pentane. Now that's not the name. Chlorine are there. What will this chlorine do? It will go in front. We'll write it in front. What we'll write it as? Chloropentane. What type of pentane? Chloropentane. What type of pentane? Chloropentane. Where are the chlorines attached? First chlorine at position 2, second at 3. So 3 and 2. So it's 2, 3 chloropentane. It's 2, 3 chloropentane. Clear? 2, 3 chloropentane. One chlorine at second position, other chlorine at third position. 2, 3 chloropentane is the name of this structure. Clear? Understood? Okay. Next one is question 1H. Next question is question 1H. Question 1H it shows CH2, let's see, CH3, CH2, CH3, CH2, 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 CH3. Okay. Now, here you have to see that which particular thing is giving you maximum number of carbon atoms. This picture might seem a little bit complicated, but it is not actually. You have to just check out the parent carbon chain. Guess the parent carbon chain properly. Now your question might be like how to guess it properly. Now guessing is not the factor. You just need to properly see which possible carbon chains are being formed. Now see, one carbon chain is this much only. Now no one has said that carbon chain has to be a straight chain. You already know that. So it can be a bent chain also. So one is this much, which is already 3, cannot be possible. So it's very small. You can see more are there, right? This is also 3. This is also not possible. Next, now we are taking a bent one. First bent carbon, this much. How many? 4. So 3 we are not going to take. Next, we are taking from here. How many? 3. That is also not possible only. So from here it is coming 3. Next, we are taking from here to here. How many? 1, 2, 3, 4, 5, 6. 6. So 4 will also not work. 6. Now, from here we are taking till here. How many? 1, 2, 3, 4, 5, 6. That is also 6. Fine. From here we are taking 1, 2, 3, 4, 5, 6, 7. How many? 7. What is the maximum carbon? 7. What is the chain? Understand. Chain is from here to here. Entire chain. This is the entire chain. Understood? So it can be a bent chain, it can be a straight chain, depends on what the structure is. So you have to see what the structure is, not what you think. Correct? From the structure you have to think, not on your own. So how many carbon possible? 7 carbons possible, right? What is the root word? It's hept, right? So what we will write? Hept. Hept. All single bonds? Fine. So it's N. Heptane. Who is attached? Methyl. Which carbon? 1, 2, 3, 4, 5, 6, 7. From here if you level, it's too far. You can understand that. Correct? So from here it is leveled at 3. So it's 3-methyl heptane. Understood? It's 3-methyl heptane. It's 3-methyl heptane. Why? Because we have taken the main carbon chain from here till here. From here if we number it, it will come lot far. 1, 2, 3, 4. 4 it will become clear. That is not P1. So we can get it at 3. So we are numbering it from this side. We are writing it as 3. 1 methyl, methyl. 1 only. So 1 only methyl, no dimethyl. This is 7 carbon. So it's hept. All single bonds N. So it's heptane. Understood? Understood everyone? Next question we are moving on to is question number I. Question number I. This is again not a very difficult question. It's a common question that's like this. Functional groups have not yet been introduced. Question number K onwards, the functional groups enters. Okay. Question number I. H3C, C, double bond C, CH3. Here is one H, here is one H. Okay. So we can write this as modification. Okay. Modification is CH3, CH, double bond CH, CH3. Correct. If you are having problem from here, write it like this. No problem is there. Clear? Now, from here can you see how many carbon possible? Chain is always this one only. From in this case, straight line, only one chain is possible, is this one. Okay. So this is possible. How many carbon? 1, 2, 3, 4. 4 carbon. So total will be but something. Now, from which side should be label? 1, 2, 3. Between 2 and 3, from here 1, 2, 3. That is also same. So the other side you can do it. Okay. Either side you can do it. Next. So it's 2 in. Clear? Very simple one. It's in because double bond is present. Position is 2 and 3. So 2 position comes over here. 4 carbons possible. So it's but. Clear? 4 carbons possible. So we have written but. Understood? 4 carbon possible but written. Second position and third position between double bond. So second position written and double bond is present. So we have written in. Understood? Clear? Next question. Question number J. That I am not going to do. That you will be doing and sending. Okay? In the group, that link is being provided in the description. You can join that group and you can do this question number J, and send it over there. Okay? Okay, this is an easy question. Okay, this question J is an easy one. Okay, now let us move on to question number K, and from this question you will be finding the introduction of functional groups. So now you have to be a little bit more careful because now functional group has entered. Next, double bond will also enter in the same condition. Okay. Okay. Question number K. Understand, it's given as CH3, here also CH3, here also CH3, here CH2, here CH2, here CH2, here CH2. This person can you identify? Who is this person? Not a stranger. It's aldehyde. Correct? CH2 is an aldehyde. So this is not a stranger. Aldehyde has arrived. Fine. So aldehyde is a functional group. Whenever aldehyde is present, we end it as Al. Correct? Al we end it as. Right? So Al will be ending it as. Fine. Acha, numbering will be done in this way or this way? This way. This way. This person must get the lowest priority. Right? This person must get the lowest priority. Lowest priority, it will get the highest priority. But by lowest priority, I mean the lowest locant. Okay? So lowest locant. 1, 2, 3, 4, 5, 6. So lowest locant it should get. So this is 1. Position number 1. Right? Numbering started how many? 6. So it's hex. It's hex. Correct? Hex. I will be writing the hex later on. First let's take this part. Which carbon? It's attached to the 5th carbon. Correct? 5th carbon. So it's 5, 5 dimethyl. Any problem? Any problem? 5, 5 dimethyl. Now I am writing hex. Position 1. Hexan al. Clear? So it's 5, 5 dimethyl hexanal. Understood? It's 5, 5 dimethyl hexanal. Clear? It's hexan 1 al. So I have not mentioned the 1. You can also write it like hexan 1 Al. Clear? That's also same. I have written hexan al. That's also same. So we have taken the main chain as this straight chain. Wherever the functional group is present, we have to take that as main chain. This is the main chain. Now 2-methyl is over here, so dimethyl is over here, one di, then both are attached to the 5th carbon, so 5, 5 dimethyl, total is number 6, so we have written hexane, hexane because to indicate that all are single bonds. This is aldehyde, we have written position is 1 you can write, cannot write, same thing. Clear? Understood? Next question is question number L. Question number L. Now, question number L, you will find alcohol. Question number L, you will find Mr. Alcohol. Right? Mr. Alcohol? Yes. Let's write the question. Question number L, CH3, CH, CH2, CH2, CH3. Here it is Mr. OH. So, functional group gets more priority. So, we have to number in such a way that this person will get the lowest possible locant. So, we cannot number it from this side. Highest possible locant will be getting. 3 are already here. So, 1, 2. So, 1, 2, 3, 4, 5. Correct. So, which position? Second position. So, first, how many carbon? 5. 10th. Position 2. Last ending with all. All is for alcohol, right? So it's pentan 2 all. All was for this person. All was for this person. 2 is for the position. Pentan is for the total number 5. Clear? So number is from this side will go wrong. Okay? Understood? Okay. Next question. Next question is question number M. Question number M. Let's see. CH3, CH, CH2, CH2, COOH and CH3. What is the name? What is the name? Understand? So what is the name of this? One familiar person you are seeing is this person, carboxylic acid, right? This is COOH. Okay. And it's fine, carboxylic acid ends with oic acid, right? So 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5. 1, right? So this will be 1, 2, 3, 4, 5. This is oic acid. How many total? Pen, tan, 1 oic acid. Is that the only name? Is that the complete name? Is that the complete name? No. Where did this person go? Methyl is also existing, right? So we have to write 4-methyl pentan 1 oic acid. Correct. 4-methyl pentan 1 oic acid. Clear? It's 4-methyl pentan 1 oic. Oic acid stands for this personality. CH3 is methyl. Fourth position is this. Oic acid is at what position? So it's in 1. Understood everyone? 4-methyl pentan 1 oic acid. Understood? Okay, next question we are going to do is question number Q. Next question is question number Q. Seems like a very small question, but yes, it's a confusing question as well for many. See the question, it's HC double bond O. Okay, this is the question. HC double bond O, single bond H. What is this? If you compress it, you will get it something like this. Can you identify this? Al, and this is only hydrogen, nothing else is there. What is this? What is this? Where only hydrogen is there and there is nothing there. Formaldehyde. Correct. Formaldehyde, how many carbon? 1. So it's methanal or methan 1 al. Correct. 1 carbon is present, nothing else is present, only 1 carbon is present and this functional group is present. It's al, it's methanal or formaldehyde, the common name. Formaldehyde is the common name. Methanal is supposed to be written as the answer to this question. Clear? Okay. Next question we are going to do is question number T. Question number T. Next question is question number T. See, question number T is also easy. You have to just observe what is going on. Okay, what is this? Can you get something with this? I have told you that in carboxylic acid, 1 carbon is bonded to this person, 1 carbon will be bonded to this person, 1 will be bonded to R. Haven't I told this? Observe this formula and you will get this also. See, compress this, will get CH3 bonded with this. What is this? This same thing. Clear? One is OH, one is this CH3. So this is what? Carboxylic acid, correct? So this structure falls in carboxylic acid. How many carbon? 2 carbon. This is 1 carbon, 2 carbon. So it's how many? 2. So it's ethanoic acid. Clear? It's ethanoic acid, acetic acid, common name. Okay. Ethan 1-oic acid. Understood? How did we do? We saw this part. We already know that in case of carboxylic acid, we have 1 carbon bonded with oxygen double bond, 1 we have is with an alkyl radical, 1 we have is with alcohol group. So all are fulfilled. It's a carboxylic acid. Okay. Next question. Question number U. Question number U. Same observation type question that you have to see. HCH. Okay. HCH. Then is given is C double bond OH. Okay, again understand, carbon is there double bonded with one side R, one side H. Tell me what is this? What is this? Aldehyde. R bonded with CHO. What is this? Aldehyde. This is aldehyde. This is R. R bonded with CHO is aldehyde. R is alkyl radical. R in organic chemistry is always alkyl radical, nothing else. R is alkyl radical. So alkyl radical bonded with aldehyde is aldehyde. So it's al. Clear? So it's al. How many carbons? 2. So it's ethan 1 al. Clear? Okay. This portion is your aldehyde. This portion is your CH3 aldehyde. Can we give ethan 1 al? Okay. Next we are going to do some structure drawings. Not all. We are going to do 2 structure drawings. 2 structure drawings we are going to do now. First one we are going to do is question number 2, part F and part G. Okay, part F and part G. Let's see what is part F. Part F says 2-methyl prop 1 in. 2-methyl prop 1 in. Okay. First you have to check the root word. How many? Prop. Number 3. So 3 carbon. 1, 2, 3. Double bond is said no. So let's write double bond. So numbering will begin from 1, 2, 3. Understood? Acha. 2 methyl. So 2 is over here. So CH3. Now satisfied everybody? 2. Now let's remove the numbering. So how many more? 2 more. So like this, right like this. How many? All done. 1, 2, 3. Clear? This is the structure asked. Understood? This is the given structure that is being asked in the question, and you have answered in the answer. Okay? If we wish to start in the other way, like if you are putting it this side, fine, it's fine, you can do it. But the main thing has to be, it has to be put between the first and second carbon only. Nothing else. Though you cannot put it anywhere else also, but please still, okay? Might be your property is butane. In that case, you have to think. If you place it between 2 and 3, it's wrong, okay? In case of butane, I'm talking about. Okay, next one is alcohol with molecular formula C4H10O. Alcohol with molecular formula C4H10O. Now this is not very difficult if you are thinking so, because the IUPAC name is not mentioned. Well, how does that matter even? In this case, let's see, C4H10O. C4H10O. You just name the compound. That is only easy. That is only easy. See, this is alcohol. First of all, this is not alcohol. This is C4H9OH. You have to modify C4H9OH. Now it is an alcohol. What type? Butanol. It's butanol. Correct. So 4 carbon. OH is at first which position? Position number 1 definitely. So we will be keeping it at this side. OH. Numbering starts from this side. 1, 2, 3, 4. 2, 3, 4, 5, 6, 7, 8, 9. 9. Okay, 9 carbons are possible. So fill up this with hydrogen. Done. Very difficult? No. Just going to see whether it is okay or not. Okay. 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 So that was all from this part, drawing and naming of certain structures, and from the given names, drawing structures. So it's not at all very difficult. If you can understand it, it's easy. If you are having confusion, you need to repeatedly practice it. Okay, so hopefully you all have understood this concept and you all can name structures now. So hopefully you have watched the previous video as well, because if you have not yet watched, then you will not understand this properly, because rules have been discussed previously and you are coming towards the next video without watching the rules. It's like, what to say, like it's not knowing the basics and coming to know the advanced, like that. Okay, so watch the previous video and come back to this video to watch this. Hopefully you all have liked the video. Keep watching. New video will come very soon. We will be dealing with the next part, alkane, alkene and alkyne. Okay, see you all in the next video.